Okay, we're going to start computer and internet communication, and this is the first part of, I believe, all communication, because everything is going to the computer, internet from now on. Everything is connected, so we kind of want to know a little bit about the computer and the internet. Most of you kind of are aware of what the computer consists of. If you look at it and you can physically touch it, it's going to be called hardware. So most of all hardware is something you can touch. Your monitor, output devices, input devices, the system itself, keyboard, mouse, etc. So there's quite a bit of hardware on the machine. Here's the four main units of hardware. You have your CPU. We consider that the brain. Okay, so if there's something you want to definitely write down, that this is the brain of the computer. It does all the processing for you. Okay, so we have the brain of the computer. If you notice, this right here is the CPU. It's a little microchip. If you've ever opened a computer before, it's covered by a fan and some like rib-like metal. It's there to keep it cool, because again, it does everything for you. Okay, so we have the brain of the computer. We have memory. There's two types. We have RAM and ROM. The RAM, as you see here, this right here is called your RAM card. Right there. You can purchase those at Walmart, add more to it, and typically, if the more RAM you have, the faster your computer will go. Okay, so most now the computers in the lab are between 2 and 4 gig. The brand new thin ones, they're actually 8 gig of RAM, and we'll explain kind of what gigs represent here in a minute as well. So we have RAM and ROM. RAM is used only when the computer is on. It's temporary. We basically use it to crunch numbers. Then the ROM is the permanent memory. That is your hard drives. This stuff right here, these are hard drives. These are internal hard drives. These two right here are considered your ROM. CD-ROM, DVD-ROMs, your external hard drives, your external flash drives that you guys carry around. Those are the ROM memory. So those are permanent. They cannot be changed once it is created. Okay, and then the last two units of hardware is your output and your input devices. Output being something that provides information from the computer to you, for example, the printer, and then input is providing information to the computer, which is your mouse and your keyboard. Okay. Now that's hardware. Now we'll move on to software. Software is the stuff inside the computer that makes the hardware work. So they're known as programs. You know a lot of these things, software or programs. You've heard of them before. Microsoft Word, Office, AutoCAD you've already used, PowerPoint, Photoshop. We can keep going on and on. And what it does is those have a set of instructions inside of it to tell how the screen's going to look like when you click a certain button. So that is the driving force of it all. And again, software you can buy, and typically anymore you buy them on CDs, or you're getting downloaded from the internet onto your computer. Okay, I want to talk about binary code real quick, because it's very, very important to understand it. This is the only way computers can talk to you. It understands nothing more than a 0 and a 1 put into a sequential format that only the computer understands. And then, for example, it takes all these zeros and ones and puts them into a pattern. So then you see red dots, or you see a picture, you see numbers and letters. When you hit the enter button, it creates that enter into zeros and ones, so it understands exactly what's going on. Okay, if the 1 by itself or the 0 by itself is called a bit. Okay, together, or by themselves, individually, they're bits. And if you have 8 of those together, they're called bytes. Okay, I want you to understand what this is. I'm going to draw a little diagram. You've seen this before. Is an on and off button. If you look at most of your devices, they have this. Okay, what this represents is 1 means on. This equals off. So sometimes you might actually see this type of on and off switch. That means it's just a button that turns it off and on. Or you might actually see a device that looks like this. It has the switch, and it has a 1 on top and a 0 below. That means 1 is on, 0 is off. So binary code's been around forever. You can see it in all your switches. You can see it in, go home and go to your vacuum, look at the vacuum tonight. Most everything follows this pattern. So that's how a computer reads. All it is a bunch of switches put together on and off to make a pattern so it can read it. Now if we go through and again if we put 8 of those together, they're called a byte. Okay. Now I want you to understand kilobyte. Kilo means 1,000. Then we have megabyte. Mega means 1 million. Then gigabyte, 1 billion. So we have all these different things we're going to work on. And I'm kind of give you here's my youngest daughter, if you know her, or not my youngest, my oldest, excuse me, Kaylee, when she was a kid. This is a photo I made, and it was at the time 5 megabytes. Okay, what that means is 5,242,880 bytes. That means there's that many combinations of 8. Now, if we take those into bits, which is the bytes times 8, you get 41,943,040 bytes. That is zeros or ones. That means there's 41 million, almost 42 million zeros and ones that make up that image. That's kind of impressive. Okay. Then if you look down below, just a gigabyte. I want you to understand what a gigabyte is. As we said before, 1 gigabyte represents roughly 1 billion numbers. So, or 1 billion bytes. Well, here is how many zeros and ones is 1 gigabyte. You get 8,589,934,592. That's how many zeros and ones represent 1 gigabyte of information. That's a lot of numbers. Okay, and we're going to kind of go through a little exercise when you get back, but I want you to do this next one with me. So you need a sheet of paper, and you'll write this down. Hopefully you're taking notes so you can do it right there on your note sheet. The simplest form of binary code is in powers of 8. Okay, we're actually, this is, we're used to the tens power. So like if you have 10 tens, that's 100. Well, in binary code, it's 2. So everything is multiplied by 2. So if you notice, we start on the right and work left. And if you notice, there is a pattern. It doubles up. 1 times 1 is 2. Or actually, 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And so on. If you notice, you counted how many digits there are. We have 8 digits. That is how many bytes that we have. Excuse me, how many bits we have. We have 8 bits in a byte. So if we look at this, we got 8 bits together to equal 1 byte. Now I'm going to do, again, the simplest form. And to get something, all we got to do is turn switches on or off. If we notice, if you remember, a 0 is off and a 1 is on, so all we can use is either the 1 or a 0. I want to create this. Well, you can't see that. Let's try again. Okay, so when you log on to someone's computer, it is, or let's, for example, Facebook. If you get on Facebook, Facebook is a file on someone's computer. You log in, you put all your information into that website. That information is now on their computer. You trust them with your information, your pictures, your phone numbers, whatever you put onto that computer is now in their possession. You do not have control of that once you do that. So you got to understand that web pages are very, very they're very important to understand that you cannot put everything you want on there. Otherwise, it is somebody else's to take a hold. Okay, I've got binary code. This is the simplest form. I want to show you some things. I know I already went over the 1 times 2 is 2 and so on. But I want you to do this number in binary code. And again, all the computer will know is either an on or off, which is zeros and ones. On is 1 and 0 is off. What we're going to do is go across from left to right, adding up all the numbers that make up 82. If we don't need the number, we turn it off. For example, 82 is the number. Can I add 128 to something to make 82? The answer is no. It's way too high. So I'm going to go ahead and turn off 82. Okay. Is 64 needed to make 82? Well, hopefully you guys realize the answer is yes. So we're going to turn it on. 64 plus something will equal 82. So let's go down the list. 64 plus 32, that's going to give us 96. Way too much. So I don't need that one. I'm going to turn it off. 64 plus 16, well, if you did the math, that's actually 80. We'll turn it on. So we know we have 80. We need 82. So we already know we can go ahead and turn this one on, and the rest we can turn off. So we have an 82 in binary code. So let's go ahead and write it out. 0, 1, 0, 1, 0, 0, 1, 0. And again, that's 1 byte of information. That equals 82. Pretty neat. But that's how a computer reads. Again, we just did 1 byte. Just think about the ones that have 8 gigs of RAM. They're processing 8 gigs of information per second, where we did 1 byte in about 30 seconds or so. So we'll do a little trick, a little problem in class. What I want you to do is this number right here as homework. So you do 75 in binary code on this same sheet of paper, bring it in, and that'll be your quiz. If you do this, you'll get your 5 points. If you don't, obviously you won't. So make sure you do this 75 in binary code. Okay, I've got the internet domains. I want to talk about them real quick. I know there's some here I do not want. I want you to cross off this one, military groups. We don't really use that, or INT anymore. They're still around, but we don't really use them. The main thing I want you to do is know .gov instead of military, which you guys should know. It's the government organization. One of the main things that you're going to use is .coms. Those are commercial organizations. And the other one is the .org, which obviously you know, Frontenac249.org. EDU, pittstate.edu. All these are pretty good ones. The most common you'll use are these 5 that you'll come across. So understand those, and you'll be fine. In this last one, I kind of went around it earlier, and we made 2 videos. I'm merging them together. But I just want you to know that a website can be created from any program. Okay, you can have Microsoft Word and type in Mr. Goody cures cancer by eating chocolate. You can type it in Word, you go File, Save As, and it has Save for Web. And what that does is saves it for this right here, .html. So instead of the normal Word document, which is your file .doc, that's the Word document. If you go File Save As for Web, it'll change the .doc to .html. Okay, and then it's a website. Then all you gotta do is pay some money to have it on the web. Excuse me.